Yeah. So I thought we should talk about the goal during the break, but we didn't do that. We talked about other things, but it was a break, so that was it. And anyway, you have to figure out what your goal is until next time. Because sometimes you have a goal that is really big and it won't work within the time frame that we have. Or you have a really small goal that is sort of accomplished in a week. So even if you think you have a goal, maybe you have to adjust it. But at least get one. Okay, here are some other, here's the list of computer languages. It's the top 10 computer languages. The first one is Java, C, C++, Python. Yeah, I forgot to mention Python. That's also quite common in research because it's free and works. And there are some packages that you can use which are makes it kind of similar to Matlab in terms of processing. Visual Basic, PHP. Matlab is ranked 27, I think it was. But of course this is over the whole world, so within academia it's more common. And for some fields it's like the gold standard, you can't get away without using Matlab, like neuroscience is one of those. Yeah. So the different languages are in a way very similar. So here's a function, really easy function that only says hello world in the command window. There's a function name, which is hello, and there's a block of code. So the block is defined by function and end. But in Java, it would look something like this. Class and a package name, and then in this programming language you use curly brackets to mark block of codes, and functions are defined by using these things, and again there's a block within the block here using curly brackets, but it sort of it will do the same thing. And here is C++. You've got the function, you've got curly brackets to mark the block of codes. And it looks very different to Matlab, but we'll do the same thing. PHP, a bit more like Matlab. The function is declared by function text and the name. But you don't have an end, you have these curly brackets. That seems to be kind of common. This is a unknown, or not unknown, this is a artificial programming language which will say hello world. But I don't understand it. So these are different languages. They can look very different, but they do the same thing. So why do we choose Matlab when we've got all these other options? Of course, this one is quite obvious why we don't use it. It doesn't really make sense. But the other ones, well, kind of similar. But Matlab is, I think it's a kind of easy to learn language because it's high level and not many other people know that. So in order to learn, it's good to ask your colleagues or friends, how would they solve this task? Or how do you make this expression in this language? So that's good. And high-level programming language means that the language or the computer will have words that will do kind of complicated things. A low-level programming language you would only have a few set of instructions to the computer, and then you have to combine them into bigger blocks and sort of create your own language. But in MATLAB, most complicated things are already built together in functions. MATLAB is cross-platform, so you can use it on different platforms. I don't care if you use Windows, Mac, or Linux, or whatever. It's good at mathematics, which we often need to use in research. It's good at handling large data amounts, and it's really easy to visualize the data. I think that's why MATLAB became so popular. We could handle big data and we could make it interpretable. And as I said before, it's sort of golden standard for some tasks. We just have to use it. However, there are some downsides with MATLAB. The memory handling, surprisingly, doesn't work too well all the time. It has some memory leaks, so sometimes you will crash your computer because MATLAB didn't handle the memory correctly, and that's when you start programming, it doesn't matter. But I've had issues when I wanted to make graphical user interfaces and so on. Which the second bullet is user interfaces, and MATLAB doesn't really play well together. It's kind of difficult to make something look good in MATLAB, and it's bad at media performance. So if you want to make video analysis tools, which I've done, it's slow. But although it's not perfect, we can still use all these things. So I'm making user interfaces to make it easier to interact with my programs, and I use it to display and create media. So it's not a big problem. But did you have
yeah, this is probably embarrassing, but I have lots of videos that I need to analyze, and I analyze it by hand. So I want to know how to do that.
Yeah.
Okay. Yeah.
Depends on what kind of things you want to analyze.
Yeah.
Within our lab, we use it to sort of track objects that move on stimuli to create areas of interest and look. We use eye tracking, so people are looking at these videos and we want to know if they are looking at different objects.
Right. So I'm looking at like movements. It's actually when they start moving, I want to start timing, and until when do they stop moving, because I want to know the time frame. But then I've also used something called track. I forget. We have like 8 cameras tracking movements, and then we have.
It's a motion capture system.
Yes.
Of some sort.
Yeah.
Meaning
so
that you've actually got the movement.
I do.
And that will be much better to use.
Okay.
Because the video always have a quite slow frame rate.
Yeah.
Typically, so you won't get good resolution. And if you have a motion capture system, you can create velocity profiles. Then you will get peaks in the data when they sort of move their hands fast. And if you can also get the acceleration, and the peak of an acceleration will indicate the onset of the movement. And finding peaks isn't that hard in MATLAB. There's a function called find peaks.
Find peaks.
And if you
I'm going to look for find peaks.
Yep. So we can solve that. So then you don't need to go into video coding.
No, let's not go there. Yeah, I'll do the rest by hand.
Yes.
No problem. We have all that EEG data and the motion tracking and all sorts of data in the same. That's the same experiment, because we have some data overload, I think, in that area.
Yeah. Yeah. Okay. let's get started. That means that I should start Matlab and see what it looks like.
Yay.
Oh, by the way, Matlab won't look the same for you because I sort of customized my environment, so let's see if I can get the default. Probably looks like this for you. And you've got many different windows. I think the most important one is the command window. This is where you can type things, or 1 plus 2 is 3, or we can actually make the logic problem. A equals 1, B equals 2, C equals A plus B. So the command window is where you start your code, sort of, or get output. I only have the command window open and the editor where I write my programs, but that's a matter of preference. So the other part is the editor, and I want them as tabs so I can have several functions in there, and I usually drag this window outside of the main window because I don't want it, and then I close the workspace and things like that because they just take a lot of space, I think. I don't use them. But I think you should use them in the beginning because you will see what variables you have in memory and how they are structured. So going back to the slide, we have command window and the MATLAB editor. I think these two are the most important for me. But then we also have a workspace window showing which variables you have in memory. That's the only things that you can manipulate. So if you have a text file, before you can do anything with it, you have to read it into MATLAB's workspace. So that's the memory of MATLAB. And then you also have the current folder window and the history window. So you can click around and drag files into the command window and so on.
Okay, so maybe a stupid question, but I don't have my editor open at the moment. So how do I open the editor? I want to open it.
I think it's under the layout, but actually
Or maybe.
you can click this new script, then it will open.
Okay.
Yeah.
Right. Okay, yeah, that's it.
And then you will get the new script.
Because it always opens by default when I open some script, I guess.
Yeah.
Thank you.
But it takes a bit of time to get used to the environment. It always does. And if we start, what we're supposed to know for this lecture is that we've got numbers. Okay, so MATLAB knows numbers, but you can also arrange them in a row, like a series of numbers, or a row is like that. You can have them as a long row or as a long column. That is called a vector. That means that it's just a series of numbers. Or you can have these numbers in a matrix, which means you have rows and columns, very much like Excel and SPSS. And I think that's a very good metaphor. I often think of MATLAB's memory as a spreadsheet, which I don't see at the moment, but it's hidden under the hood somewhere. And MATLAB means matrix laboratory, and doesn't have anything to do with mathematics. So sometimes when I have this course, people are terrified about MATLAB because it sort of sounds like math. That's not why they wanted to read psychology. They didn't want to do math. But it actually means matrix. So matrix is a general form of structuring data in MATLAB. So if you have a function that will do something, for example, calculate a mean value or a standard deviation, you can give a matrix to this function, and you will get out another matrix or a vector or a number, depending on what kind of function you call it. So that's the most basic thing, and this is what you're gonna practice for the assignment. So here's a vector example. If you type this in the command window, A equals, and then hard brackets and numbers. You can do that right now. We'll see what happens. It will create variables, which in fact is like a spreadsheet. And you can make vectors very easy by using the colon command. So in the last example, C equals 3:7 is exactly the same as the row above. So colon means take the integer value between these values that you specify before and after. So this, I think you should all try to write this in the command editor command window and see what you get. So this is how you can create a matrix, but now you want to get things out of it because you want to do something with it. You want to read what's in there and so on. And then you use parentheses. So if you take the variable name, parentheses, and the index of the number, you will get that. The index really means the position in your vector. So if you take A3, A parentheses 3, you will get number 7 because it's 1, 2, 3, number 3. That's it. But this doesn't sound very groundbreaking. But once you start looping over things and adding dimensions, it becomes really powerful and gets complicated quite quickly. Here's a matrix example where we have 2 dimensions. And you do the same thing, but to add a new row, you have a semicolon. So you can just make it short matrix. And then to get the number out of that, to get a specific value, you can use parentheses and use an index with row and column. So in this example, A parentheses 2, 3 contains number 9. Means the second row and third column. already now we will learn about what happens when you make a mistake. So if you take position 0, that means you're in column 0, which doesn't exist. Or row 0 or row 7, it's outside of your matrix. So MATLAB can't get you this number. Then you will get an error. Red text in the command window, which says matrix out of bounds.
Index in a position 2 exceeds array bounds.
Yes.
Must not exceed 4 in this case.
Let's see how we can do this. Yeah, index in position 1 is invalid. Array indices must be positive integers or logical values. Or exceeds array bounds. So we also get a little sound saying bring. You'll learn to love this sound during the course and this red text. But actually, most people don't read the text before they contact me when they have problems. They say, it doesn't work. Why doesn't it work? And I ask, what does the computer tell you? And they say, I don't know. Or they read it, but they don't understand it. What does it mean? Index in position 1 is invalid. Array indices must be positive integers or logical values. I think many people think that this is very complex text. They haven't seen something similar before, so they think it's, I don't understand it. I must learn how to program to understand this. But actually, no, you don't need to learn how to program. You can actually just read it. But you have to know what an index is. And that's what I just told you. The index is within these parentheses. It's the position in your matrix or vector. So if we know that index means what's in here, then we can read index in position 1 is invalid. Okay, so the first index is invalid. We have to change this. 0 doesn't work. And it says, also says, it has to be positive. 0 isn't a positive number, it's nothing. And it has to be an integer, so we can't have 3.5. Or it could be a logical values, and I will tell you later what that is. But just from this part, we can learn what is wrong. So debugging is a lot about knowing how to read this. Or the second one, index in position 1 exceeds array bounds. What is an array? Well, that's, in this case, it's actually the matrix. An array and a matrix is the same thing. And it also gives you more information. It shouldn't be higher than 3. That's the most important thing for this lecture. Okay, and then you can do things slightly more complicated. If you remember the logical reasoning, you can try this example, and you will see that you will get an answer. For C. You can actually type this in MATLAB and you will get an answer out. And this is a matrix or vector that you're adding. And just because they have the same number, the same size, MATLAB can just add them together. But if B only had 2 numbers in there, it wouldn't work, I think. Let's try. Yep. And it says that the matrix dimensions must agree. So the dimensions, like, means the size of the matrix, must match.
But if we instead wanted to make C into a matrix of A and B, so with two rows, so not have them together, but just merge them, but without adding them.
Yeah, if you want to do that, you can do hard brackets, because that's how you define thing. And then you take A
Oh, and then some
and B.
Yeah,
Now
of
this
course.
won't work,
No, because now they are...
because they don't have the same
Yeah.
size. So it says, I can't do that. But if B was...
Of course.
then we can put them together. And actually you can do like this. If B was just a single number, then you can, then it will add this number to every,
So,
every number in your matrix. So it's a bit, no, you can do a few things in there. Sometimes it works a bit unexpected. In weird ways, but you will get an error telling you what is wrong. Okay, so if we continue, more terminology. So we just created A, B, and C. They are called variables. And variables are where you will store your data. And then we have the plus, minus, and different kinds of operators on your data. So they are called operators. And they will take your variable and do something with it. Sort of, you use operators to massage your data in one way or another. I don't use the word operators very often, but I use the word variables very often. I typically say, oh, and then you can create a temporary variable to store this information just for a short time. Or create a new variable that will store this, because then you can use it later for some reason. So variables are, we talk about them all the time. Okay, so I showed you a function before, hello world. And functions are equally important as operators. I more often talk about functions than operators. And functions are a block of code that will do something with your variables, data. So it's like a black box, but it's not black. It's like a white box, white magic box. You put something into the function, you get something else out. And it's really good because once you've made a function, it's really easy to call it and to use it multiple times. You can make functions to save time and not write the same code again and again and again. And some examples that we use often, like plot. If you want to make a plot, it actually means open up a window if you don't have a window, make sure that there's no title unless we specify it, and we make the numbers on the x-axis and the y-axis, and blah 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 blah. Lots of things before you actually make the plot. But because someone made this function, we can just write plot, and you will do something. We can actually try that. Plot A, for example. Or we can start with typing A. This is what A is, and if we plot A, we get a figure, and we get x-axis with numbers, we get y-axis with numbers, and we got 3 lines in different colors, and we didn't have to specify anything, we just wrote plot. So the function will do lots of things for you automatically. And I think knowing the name of the good functions is key to knowing how to program. So the difficult part is to know the exact name of your functions. And that's where you have a good book, or even better, the internet. So use Google, Yahoo, or whatever to find the function name, or use the Matlab help. And for every lecture, I will have a list of functions that I think you should know for the next time. This is not an assignment, but I will sort of assume that you know these functions until next time. The help function is quite good. I use that one. If you type help and the function name in the MATLAB window, you will actually get some help. So if I type help rand, I will get a lot of text saying what the rand function actually is. It's a uniformly distributed pseudo-random number generator. And if you read this a few times, you'll learn the structure of these help files. So we can type rand, parentheses, and a number, and you will get a matrix, which is the size of your number. And at the end of the help file, you'll find suggestions for other related functions, like here, randy, which is a random integer, or randm, which I don't know what it is, RNG, which I think is good for making random numbers of different distributions, which is good because in psychological research we often have normal distributed things. And if, in case we want to make models or something, or just random noise, it's good to be able to specify the different distributions. But I might be wrong, so check help. So with this list, I think you should type help and the function name. And how to know how to use a figure, you type help figure, and help plot, and so on. Now I type help figure, and we get the help text for the figure. And this is interesting because there's a reference page for most of the functions. And if you click that one, you will get to a browser with more information and examples, so you can see how to use them. So the first example is how to create a figure and specify a name. Then you can just copy this into the command window, and this will, and see what happens. In this case, you will see that this window that you created has got the name measured data, which we specified here using a name value. Yeah, we'll get more into such things later, but it's good to know that there's a lot of help around, and I often use these different help functions. Okay, so once you start programming, you start to enter, you type these function names in a specific order. But when you're talking Matlab, you should know that Matlab is extremely picky. So I've got an example here. This word is different from this word. To a human, yeah, we still understand that this is sort of, this is the same as this. Who cares if there's a capital W or not? But Matlab is really, really, really sensitive about these things and will not understand anything. So it give you red text saying, I don't understand. I don't know what you're talking about. So Matlab is case sensitive for your variables. Lots of errors due to this, probably during this course. Then we have sentences. When you end a line of code or end a statement, you end it with comma or semicolon and never with dot, because dot means something else in most programming languages. It means, we'll get into that later. But yeah. So when you end the line, use comma or semicolon. If you use comma, you will get the output of the sentence in the command window. If you use semicolon, you won't get it. So.
And if you use nothing?
It's the same as comma,
Seems
but then you can't make several sentences in a row.
Mm.
Sometimes I don't. For example, in really simple loops where I'm just outputting, for example, the name of the subjects to double check that everything is all right, I just write it in one row. And then I use comma to separate the different functions.
So if you use comma, you see everything in the command window when you
Yeah.
But if you have the semicolon, you just get the final answer,
Yes.
so to speak. Yeah.
Exactly. So you can see that if we do like this, A will give you what's in A. A comma will give you the same thing, but A semicolon won't give you anything.
Oh.
And as we said before, Matlab is good at using large data structures, and printing to the command window actually takes quite a bit of time.
Yes.
So if you output a large large variable, for example 1,000 by 1,000, variable, you've got 1,000 rows and 1,000 columns. If I type a comma, it will take some time for it to plot it, even though it's just numbers. So when I code, I usually make most statements silent, but use comma to actually see what's in there. So when I'm debugging, I'm using comma, but not otherwise. Okay, and the other thing, apart from these two things, is that the syntax is also very picky. And what is syntax? Well, syntax is the order of things, order of commands. And sometimes you have to have a space at the right place, or a right number of parentheses, or kind of parentheses. That's also quite tricky to get it all right in the beginning. And if you get anything of this wrong, you will get an error. Usually, if you have a program, a separate block of code, MATLAB will tell you which row is problematic, but sometimes it's not. You don't get that, or sometimes the problem is at another row previous to your error. And this is where the relation part with your computer comes in. People tend to get very personal about these things because MATLAB isn't wrapping the words for you. It's sort of, it's red, there's a ping sound, but MATLAB actually doesn't mean that you're bad. It's just not being polite, just telling it the way it is. And it's mostly about ourselves handling this feedback. Maybe in the future we'll get polite compilers saying what works and not. But you should remember that MATLAB isn't angry at you, even though it sounds and acts a bit angry with the red text. But you can do the same thing over and over again. It won't get more red, or like write the same output in capital letters, like read the error message, damn it. So be polite with MATLAB, don't get angry with MATLAB when it doesn't understand your intentions. It's just a computer after all. But if you're patient and sort of try to figure out what is wrong, being constructive in your relation to this thing, you'll get better at knowing what the real problem is. And the good thing is that sometimes you get stuck, but someone else got stuck in a similar way. I'm sure about it. So go out on the internet and try to find the answer. Okay. So this is a second bring home message. Errors are okay. And I make super many errors every day because trial and error can speed up things. Sometimes, if I don't know what is the right syntax, I'll just chance. And if I get an error, I know what the problem was. I get feedback, what it should look like. So instead of looking for this information somewhere, it's easier just to do it and read the error message, and then you'll get it right. So the errors will give you important feedback on how to improve as well. So that's good. Sometimes you don't get an error message, or you get the same error but only occasionally for 1 out of 10 subjects, for example. Then you probably have a flaw in your program. So that's a bug. Most people know what a bugging bug is. And debugging is just taking out all of these minor problems in your code. And I think that what takes time in learning how to program is to debug, to localize the problem and correct it. And I think the main time waster is that we're looking at the wrong place. So if the data looks weird, if we made a sort of small mistake in the beginning of the program, maybe the error comes much later. So it's important to know how to find the problem and how to visualize or look into the data at every step to see when and how it goes wrong. That's a general strategy. Okay, we're getting to the end of the first lecture. It's always like this, that we have a lecture for 2 hours, And then we have a third hour where we just sit down and program and do the assignments and work in practice. That would give me time to help you if you get stuck, and so on. So the first assignment is really easy, just to make a face. So the goal is to understand how a matrix variable works. So, and the task is to make a picture of size 20 times 20. And to make it easy for you, I've got some help here. So if you just write this, it will get you started. But before you do that, I can also show you assignment 2, which is to understand vectors and how to plot data. So the task is to plot 2 lines that intersect and 1 line that don't intersect the other 2. But what these numbers are, you can just make up your own numbers. And I also have some help here to make sure that you actually get going. And these, because these are assignments, I want you to hand them in to me. And I want you to do that in the same way, all of you. And that's to write a script. So instead of writing this in the command window, you should write a script. And the script is a text file with a sequence of commands. So if you write it in the command line, you won't have the possibility to rearrange the code or so on. But if you write everything in a text file and then say to MATLAB, do all of this, then you can use any text editor to write programs actually. And the good thing is that scripts are really easy to share. So all assignments should be handed in as scripts or functions. And when you're done, you should email all the assignments. Some assignments are that you should write, but then you can just write the text in a script. That would make it easier for me to organize everything. So a script is a list of commands stored in the text file, but the thing is, in MATLAB it ends with .m instead of .txt. And once you have that, you can just type the name of the M file in the command window and have it in a folder that MATLAB has stored to look in, and it will execute all the things that you wrote in the text file. The good thing about using MATLAB's text editor is that you get help, you get some colors to see what is comments, what are variables, what are operators, and so on. So I often use MATLAB's text editor. Well, always, actually. I think it's quite good. And once you do that, you're creating programs. So scripting is programming. So to wrap up this first lecture, this is what every novel programmer should know, that you can't avoid making errors. So just get used to it. Knowing how to debug and correct these errors are really important to know. Using others' code is really effective. So in this course, you don't need to invent your own wheel. You can just copy and paste it from the web, as long as you get closer to your goal and as long as you understand what they are doing. And when you cut and paste code, you read through the code to make sure that you understand it, and then you often realize that, that was actually quite clever. And instead of inventing a square wheel, you sort of get a round wheel the first try, and it's good. And internet is your friend. It was built by programmers who want to share information, and they really share a lot of code. So that's good. Until next time, you can find the slides at this web page, babylab.se/matlab1, and then you will actually see all the lectures. You can just click on all of them. And I will upload the videos as well. But until next week, I want you to make assignment 1 and 2, and also write down what you would like to learn from this course, what kind of data you would like to use, and your specific goal for this course, which actually in a few lectures will turn out to be your exam task. But you'll get a few lectures to sort of know your own limits. Yes, and that's it. Yeah,
Very good.
so see you next week.